Continuing with Chapter 8, we have some more sampling methods we need to talk about. So one is systematic sampling. Simple random sampling is the only type we've discussed so far, and a census in the previous video. But in this video, we're going to start with a few more. So we've got systematic sampling, which is where we use a simple system to choose our samples, such as selecting every 10th or every 50th member of a population. Maybe I have a list of 1,000 students and I pick every 10th student. That's an example of systematic sampling. So for example, you are conducting a survey of students in which a co-ed dorm in which males and females are assigned to different numbered rooms. So all the males are in odd and all the females are in even. Could you choose a representative sample when you chose every 10th room? So I choose room 1, I count 10, I choose 11, oh wait, I choose 21, right? That would mean I'm only getting all males. Well, I could choose 2 and then 12 and then 22, but darn it, every 10th room, or even just like 10, 20, 30, right? If I choose every 10th room, I'm only going to get a sample of one gender or the other. So this would not be a good way to gain a representative sample. Next is convenient sampling. This is what we all used in like middle school and elementary school when our teachers were like, conduct a survey, and we interviewed like our grandparents and our moms and all those things. So convenient sampling is when we use a sample that happens to be convenient to select. So a college student surveys students on their campus about their dietary restrictions as they walk into the library. Is this sample likely to be representative of the population of, this should say students, right? Well, I mean, it could be, but we don't know. Maybe all the students who have dietary restrictions are the ones who go eat in the library and aren't, in the cafeteria. So we'd have to really think about that. So convenient sampling can be good, but it can be really kind of biased or skewed. Next, we have cluster sampling versus stratified sampling. So I'm going to talk about this. This is one of my most requested TikTok topics as of late. So cluster sampling is when we first divide our population up into groups or clusters, right? So I'll have clusters of 2 people. These are my stick people, right? So I'm dividing my group into clusters. I keep forgetting. They're supposed to have 2 people. Okay, so I divide my sample up into clusters. And then I obtain a sample by choosing all the members within each of the selected clusters. So if I have this as my population, I could choose this cluster. That's my cat, Bobby. She's very talkative, sorry. And this cluster, and that could be my cluster sample. So that's cluster sampling. But what about stratified sampling? So stratified sampling is when we are no longer we want to use this when we're not concerned about the differences among the subgroups or strata within the population. So we first identify the strata, so I could break them up into groups, and then we draw a random sample within each stratum. So I could just choose one out of each group. So for stratified sampling and for cluster sampling, this still gives us a population of size 4, but one involves picking everybody in a specific cluster, and the other would involve picking a set amount or proportional amount from each strata. That's how they're pretty similar. So let's take a look. So which is going to be better in this example, cluster or stratified sampling? So suppose SLU, St. Louis University, wants to allow professors to choose how a $10 million donation should be allocated. Very nice. Which would be better, cluster or stratified sampling? So we could break them up into clusters or strata by departments. We could have the math department. Hey. We could have bio. We could have chem. We could have theater. We could have English. We could have physics, computer science, right? So we could break it up into all these different clusters or strata. If I use cluster method, and let's say I only picked like math and physics, math and computer science, would that be representative of the population? No, and they're probably going to want to spend that $10 million way differently than say people in like theater or English or maybe like the religion department, right? They have different priorities as a department. So in this case, stratified would be the best. So here's a possible solution to the previous question I just posed. So for clustering, we could cluster our professors by department and then use simple random sampling to collect 4 departments, but this inserts bias, right? We'd only hear from 4 departments, we're only hearing 4 voices. We could stratify group professors by their department and then use random sampling to select a proportionate number of professors from each department, for example, like 1/10 or 1/3 of the professors in each department. But we wouldn't want to fix in each number. Well, maybe we could. It'd be like the Senate, but because not all departments are the same size, right? Like chemistry department's way bigger than the history department. Things I know. So here's a brief summary of our sampling methods from simple random sampling, systematic, convenience, and cluster and stratified. So I have a few questions where I'm going to ask you to help me identify what type of sample is this. So what type of sample would this be, where I've selected every third person in a row? Well, this would be systematic. How about this one? Some woman just shouting out her window, hey, do you support the death penalty? That is definitely convenient. How about this next one? We've divided all of our county into its precincts, and then we only interviewed in 3 shaded precincts. Well, that is cluster. And last, what type of sample is this, where I divide up into strata? I have 1 for women and 1 for men, and then I picked 2 from each. Well, that is stratified. So let's go through one example. So the U.S. Labor Department surveys 60,000 households each month to compile its unemployment report. To collect these households, the department first groups cities and counties into 2,000 geographic areas. It then randomly selects households to survey within these geographic areas. So how is this an example of stratified sampling? So we've got the United States. I almost forgot Texas. Okay, so here's the United States, maybe like Michigan. Okay, I tried. And what they do is they divide it up into 2,000 geographic areas. And then they interview a few people from each area. So that's why it's stratified. The strata are the 2,000 geographic areas. And why is it important? Well, it's definitely important that we first break them up into 2,000 strata as an interview from every single strata, not just pick specific clusters, right? Because unemployment rates are going to be way different in New York City and LA versus like Wyoming or rural Utah. I'm assuming Utah's over there, right? So that's why stratified sampling is important in order to really be representative of what's going on in the country.